Hello there, Pathway people. Mr. Klein here. I am going to help you get started on exploring the Framingham Heart Study. Step number one is for you to make a copy of this spreadsheet right here. When you do so, you're going to get something that looks like this. This is the Framingham Heart Study 10-year risk calculator, meaning that we have a bunch of factors, health factors here, like your sex, your age, systolic blood pressure, hypertension, whether you smoke, diabetes. And then this one is called the lipids calculator because it includes your HDL and your total cholesterol on it. Down here, you will see your 10-year risk. If you see a 10-year risk of 1.7%, that means that based on the data that has been gathered in the study, a person with your health has a 1.7% chance of having some sort of cardiac event in the next 10 years. In other words, if there were 100 people that were exactly like you health-wise, we would expect somewhere between 1 and 2 of them to experience some sort of cardiac event. Notice down here, this is kind of fun. This is your heart's vascular, or your heart/your vascular age. So for instance, if I give you a really healthy low blood pressure there, you can see that cardiovascular age can actually be lower than your true age. And if you have something that's like high blood pressure, your cardiovascular age can be quite a bit higher than your real age. All right, so what are we going to do with this today? If you look at problem number 5. This one is looking at how age explains the risk of a cardiovascular event. So step number 1 is going to be to make your calculator look like this. A female who's 30 years old has a systolic blood pressure of 120, no for hypertension, smoking, and diabetes, 45 and 180 for our HDL and for our total cholesterol. So let's go ahead and do that. And here's the 10-year risk. Now, we're going to look at what happens every 5 years if we vary only the age of this hypothetical woman. So we're going to make the age 30, 35, 40, all the way up to 70. I'll probably just do that by saying, take this value, add 5 to it, boom. Well, actually, let's start here. Cardiovascular risk for this person is 1.2%. Now let's vary the age to 35, and we get 1.7%. And we're going to vary it to 40, and we get 2.3%, and so on. Go ahead and finish the rest of the table that way. You should now have a table that looks something like this. I want to point something out to you, and that's that if I tried to go one further, if I try to go to 75, watch what happens with the calculator. It will give me a number down here. However, there's a message or a note that pops up that says enter a value between 30 and 74. And what that message is telling us is that this 9.5 is not a number that is reliable. Here's the reason that that's a number that's not reliable. This calculator was developed using real health data from the Framingham Heart Study. And in that heart study, they only used people between the ages of 30 and 74. As a result, nothing smaller than 30 or larger than 74 is a reliable age to put into the calculator. Right. There are restrictions on all of the other values here too. For instance, for systolic blood pressure, if I put in something like 300, it's going to tell me that only things between 90 and 200 are reliable values. All right, so we've got our data here, which means that on the problem set, we have completed B and C. Now, D says we want to assess whether the relationship is linear. And there's no reason to put this into Statlet because this isn't raw data like you've been working with in the last couple of practices. This is a model. So these are already predicted values, which means that fitting a line to it does not make sense. But there is a way that we can assess whether this is linear or not. We can look at how the cardio risk is increasing by calculating the change. And the way we're going to calculate the change is just by looking at from 30 to 35, how much does cardio risk increase? Well, 1.2 to 1.7, that's an increase of 0.5% in the risk. And an easy way to calculate that is just to say, take this number and subtract from it the number above. If I do it that way, now we can get all of the changes at once. So we can see that the first 5 years of our woman's heart health life here, the risk goes up by 5%. But the next 5 years, it goes up by 0.6%, and then 0.7%, and then 0.8%, and then 0.9%. So with each 5-year interval of her life, the amount by which her risk is increasing is getting bigger itself, right? Every single year, and then 0.1, and then 1.2, and then I guess it went up by the same amount that last year. If the risk was linear with age, you would see that each one of the changes would be exactly the same. So this is telling us that our cardio risk is non-linear. It's probably something more like exponential because the changes are bigger every single year. I really want to emphasize this idea about change and linearity, that if the percent risk had been linear with age, 5 years would go by and risk would go up by amount. And then 5 years would go by and risk would go up by the exact same amount. So this and this would be the same. 5 years go by, up by same amount. 5 years go by, up by same amount. So the changes would be this, 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 and this. And you'd see that all of those changes would be the same size. However, what we had is 5 years go by and risk goes up by just a little bit. And then 5 years go by and risk goes up by a little more. And 5 years pass and the risk goes up by quite a bit. And then 5 years go by and the risk goes up by a lot. So since each one of these boom, 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 boom changes are different, that means that we are dealing with something that is non-linear. Okay, so let's continue. That answers this question. By the way, you want to paste your work right here. Number 6, I would like you to now do the exact same thing, but this time working with a male patient rather than a female patient. I think an easy way to go about that would be, I'm now going to delete the changes. Let's call this the cardio risk female. And we'll call this cardio risk male. All right. And now we're going to go through the same process, but I'm going to put this back to 30 and I'm going to change this to male. Now watch what happens to the percent risk when I change this to male. Okay. It immediately pops up by a little bit, doesn't it? Okay, we're about 0.3% higher risk for a male than for a female. And that is actually one of the things the Framingham Heart Study found was that males do generally have a higher risk of cardiovascular events. You can see that the difference is even slightly larger for a 35-year-old. And let's just continue and do this for the rest of the ages. So look where we are now. We've got the cardio risk for females at a variety of ages, and then a cardio risk for males at a variety of ages. Now, let me emphasize that this doesn't mean that every single 60-year-old female has a 5.7% chance, and every single male has a 12.1% chance, because keep in mind that this was based on fixing what your systolic blood pressure is and information about hypertension, smoking, diabetes, and our cholesterol. But what I do want you to notice is how the males are not only higher, but growing at a faster rate. Like the difference is getting bigger as time goes by. And we can see that by creating a time plot. I'm going to highlight this table. I'm going to hit the plotting button. And you want to set this to line chart. And then you want to make sure that age is your variable here on this axis, and that cardiovascular risk is your variable on this axis. And you can see it is from 0 to 20%. Okay, well, what do we get out of that? All right, here we go. See how the male curve is in red and the female curve is in blue. And at every single age, the male curve is has a greater risk than the female curve. But also, if you look at the distances between the two graphs, so look at the distances right here, and then right here, and then right here, those distances tell us the difference in risk between a male and a female. And so you can see that the difference in risk for at age 40 is, what is that, about 1.5%, whereas by the time we get to age 70, the difference in risk is over 10%. Okay, so not only are males at a higher risk, but as they age, the risk is growing faster than it is for females. All right, so I hope that gets you going on how to complete this assignment, and the rest of it is yours to do.